So here's example 4. Okay, in this example, we have a rectangular block that's made by gluing two parts as shown below. So if the block is stretched by two forces P equals 850 pounds, what are the normal and shear stresses on the inclined plane? Okay, this is actually a very practical problem. It's very practical in designing electronics, right? Since normally you need to use glue to just bond different parts together for packaging purposes, right? So in this example, is actually not that difficult. We just can focus on half of it since we will analyze the inclined plane. Right? We will analyze the inclined plane and we calculate the normal and shear stresses on this inclined plane. So we just cut it from this airplane from this inclined plane and just focus on half of it. Let's just look at the bottom half. You can also focus on the top half, but it doesn't matter. But we will just select the bottom half for our analysis. Right, let's look at bottom half, and it had a P here. So when we cut it from this inclined plane, so we get free body diagram. Right, we have added the external force. So then we will need to put the unknown internal force here. Right, outward. We get F. So this F will have two components. One perpendicular to the inclined plane. This we call it Fn. And it have another components in parallel with this inclined plane that we call it Fs. Right, here we have angle theta, right? So here is also theta, right? So based on this, we can calculate Fn and Fs. So Fn will be the normal force and Fs will be the shear force, right? So if we know the area, then we can calculate these two stresses, normal and shear stresses. But here, obviously, the Fn, first of all, from the free body diagram, so we can write a equilibrium equation that would be negative F plus P equals 0. So F equals P. Right? F equals P equals 550 pounds. Then the Fn will be F times what? Fn will be F times sine theta, right? So Fs will be F cosine theta. Now how about theta? We don't know what is the value of theta, right? So we need to determine theta first so that we can solve these two equations, right? So here, to determine the theta, we can just fully use the dimensions that have been given. So we have no A, we have no L, we have no T, right? The thickness T. So the T is useless here, right? So we can calculate the tangent theta equals what? Tangent theta equals A over L, and that is A is 3, L is 6, so 0.5, right? So theta will be inverse tangent 0.5, that is 26.6 degree or 0.464 radian. Okay, based on this, you can calculate sine theta and cosine theta, right? So this Fn can thus be determined as F is 850 times sine theta. That would be 380.1 pound. And Fs, the shear force, will be 850 times cosine theta. That would be 760.3 pounds. Then what is the area? Right, we also need an area to calculate the stresses. Right, the cross section area A is just the area of the inclined plane. Right, so that is a rectangle with the thickness T, and the width, we don't know the width. Right, the width will be so we know L and A, so the width will be square root L square plus A square, right, times thickness T. Right, we just skip all of the calculations. You can know that this is 6 square plus 3 square root times 1.5, right? So then that we got 10.06 square inch. So the normal and shear stresses can just be calculated. The normal stress theta will be sigma. The normal stress sigma will be normal force over A, 380.1 over 10.06. That is 37.8 psi. Right? Tau would be shear force over A. That is 760.3 over 10.06. That would be 75.6 psi.